Welcome to the notes for Chapter 2. Section 2.1 is about statements. The objectives in this section are going to be to determine whether a sentence is a statement or not, and to determine whether a statement is true or false. So we'll start with the definition and follow that immediately with examples. The definition of a statement is a sentence or a mathematical expression that is definitely true or definitely false. Determine whether the following are statements or not. If they are, also say if they are true or false. So we'll see 5 examples. Number 1, when does the bell ring? This is a sentence, but it's obviously not true or false, so it's not a statement. Sentence 2, Z cross Z is included in R cross R. This is a statement, and it also happens to be a true statement. So once we have determined that a sentence is a statement, then we can talk about whether it's true or false. This one is true. Example 3, 42 is a number. That's a statement, and it also happens to be a true statement. 42 is a number. Sentence 4, the set 1, 2, 3 is included in N. This is a statement, but it's a false statement. And why is that? Well, N is composed of numbers, so 1 is included in N, 2 is included in N, 3 is included in N, but there are no sets included in N, so the set 1, 2, 3 is not included in N. So it's a false statement. It's still a statement. I like math. This is not a statement. So it's not definitely true, not definitely false. It depends on many things. Depends on the people, the time, etc. Last example, the integer x is an even number. This is not a statement. Now, it might seem ambiguous, but we'll discuss that later. Such a sentence is actually called an open sentence because it depends on what the integer x is. If we had defined earlier that x equals 13, then the integer x equals 13 is an even number would be a statement, and it would be a false statement. But as it is now, the integer x is an even number is not a statement. Here are a few more examples where we will give names to each of the statements. So notation. Oftentimes we use the letters P, Q, R, and S to stand for statements. We use subscript if needed. This allows us to refer to them easily. Statement P. If a circle has radius r, then its area is pi r squared. We all know this is true. It's a true statement. Statement Q. The function f of x equals x cubed has a vertical asymptote. So think back to Algebra 2. You can picture the graph of f of x equals x cubed, and you can conclude that no, the function f of x equals x cubed doesn't have a vertical asymptote, so statement Q is false. Sorry. Statement R. The square root of 2 is not an integer. This is true. The square root of 2 is irrational. Statement S sub 1, all right triangles are isosceles. This is a false statement. The most well-known right triangle, the triangle 3, 4, 5, is not isosceles, for example. Statement S sub 2, the intersection of the set 0, 1, 2 and N is the empty set. If we think about it, the intersection of the set 0, 1, 2 and N is actually 1, 2, so the statement S sub 2 is false. Finally, statement S sub 3, statement Q is false. So here we have defined statement Q earlier. If we go back up here, statement Q, the function f of x equals x cubed has a vertical asymptote. We had determined that this was false, and therefore statement Q is false is true. So when we give names to statements, and if a statement involves a variable, then we can put this variable in parentheses. Think of it as a function f of x, for example. If a statement or sentence P involves a variable x, then it can be written P of x. We'll just talk about a counterintuitive example here. Statement P, the solutions to the equation ax squared plus bx plus c equals 0 are given by the quadratic formula. How could we rename the statement using the notation above? Well, it's not P of x because the statement doesn't depend on x. The statement actually depends on the values of a, b, and c. So if we want, we should rewrite this P of a, b, c. Lastly, the definition I mentioned earlier, a sentence P of x whose truth value depends on the value of x is called an open sentence. So that's it for section 2.1. We defined what a statement is, and we looked at whether statements are true or false. Thank you.